There's four major types of thermal sensors, of which all but infrared sensors are commonly used in embedded systems. A thermocouple consists of two wires of dissimilar metals joined at the heated end or junction and connected to circuitry at the other end. The voltage read by the circuitry is proportional to the temperature at the heated junction. Thermocouples can measure temperatures up to 1800 degrees Celsius. As such, they're very popular for metal and semiconductor fabrication. A resistance temperature detector, or RTD for short, works under the simple principle that the resistance of metal increases as the temperature increases. And for platinum, the most common metal used in RTDs, the relationship is nearly linear. RTDs can measure temperature up to 800 degrees Celsius. They are more precise and more stable than thermocouples, and as such, they're popular in the pharmaceutical and biotechnology industries where processes must pass strict audits for accuracy and repeatability. A thermistor is made of sintered semiconductor or metal oxide particles. NTC thermistors exhibit a large decrease in electrical resistance for a relatively small increase in temperature. And even with the severe nonlinearity, they are very accurate. Their small package size makes them ideal for measuring temperature in phones and computers. An infrared sensor is the only non-contact temperature sensor. As such, it's excellent for measuring very high temperatures safely from afar. They're commonly used to measure temperatures in hostile environments. For example, firefighters use them to know if flames are burning behind a wall in a burning building. An infrared sensor calculates the surface temperature of an object from that object's emitted infrared energy. Infrared sensors are normally packaged inside a handheld thermometer and not integrated directly into embedded systems. For that reason, we won't be exploring these sensors in depth in this course. The technology used in thermal sensors determines its suitability for applications. Each of the four types of thermal sensors has its limiting aspects. Thermocouples have the highest measurement range of any thermal sensors. If you need to measure temperatures at 1800 degrees Celsius, you have no choice but to use them. However, they're also subject to drifting over time as their metallurgy properties change with large numbers of thermal cycles. They need to be recalibrated yearly. So, if you have an application that doesn't need to measure such extreme temperatures, you might want to choose RTDs or thermistors. RTDs have excellent accuracy and linearity. They're stable over many years and there's no need for annual recalibrations. However, you need to provide an accurate current source for RTDs. You can measure temperatures only up to 800 degrees Celsius, and you also need to use either a 3 or 4 wires for each RTD circuit in order to null out the effects of lead length on the resistance measurement. And more about that detail when we get to the videos about RTDs. So, if your embedded system can't handle those details and you really don't need such high accuracy, try another way to measure temperature. Thermistors have similar attributes to RTDs. They're accurate, they're stable, and they're really easy to package. But they have messier limitations. They measure only up to 200 degrees Celsius, and their high degree of nonlinearity requires a boatload of programming in your embedded system to handle. So if you don't have extreme space limitations and you're not into firmware, RTDs might actually be better for you. Infrared sensors can accurately measure extremely high surface temperatures of objects, but they have issues too. You need to know the emissivity of the surface accurately to get an accurate surface temperature. And when you point that infrared thermometer at that surface, you need to know that the surface you want to measure is fully contained within the field of view of the infrared lens. And that's not an obvious thing to determine if you're very far from an object. Furthermore, what if you want to measure the temperature inside an object? That rules out infrared sensors completely. Let's recap. We discussed the 4 major types of thermal sensors, describing their attributes, their limitations, and reasons to select one over another in applications. In the next video, we'll take a deeper look at the technical specifications of thermistors.